Hi, everyone. My name is Alex Golec, and I'm a software engineering manager at Reddit. And previously, I was a software engineer at Google. Interviewing.io has asked me to break down some popular recorded interviews and to provide my perspective on what candidates are doing right and what they could be doing better. So today, I'll be watching a mock systems design interview conducted by an experienced interviewer with a candidate who came into interviewing.io for practice and for mentorship. But before I dive in, I just want to say I've spent years interviewing candidates for major tech companies, and everything I'm saying here is in my personal capacity. I'm not representing Google, Reddit, or any other organization. Everything you're about to hear is my personal views. So let's get into it.
My first question is, you said that million participants joined the platform and they solved code in shown during 1 hour. Does it seem something like similar to lead code contests where we have?
Yes.
So similar to lead code contest. So basically we have a predefined problem, right? And all people should solve this problem within a dedicated amount of time. And they have an access to pass the code and to run it within the browser, I guess, and to validate their results. And if they solve it properly, so all the test cases are passed, they finish their part, and we place them to the leaderboards based on some ranks. I guess it should be something like number of attempts, speed of the solution, and memory required for the solution. I guess something like that, right?
Yes.
Okay, so let me prepare some sort of template here. Functional requirements, functional, non-functional. We'll see if I will need to some sort of capacity estimations and high level. Should I concentrate on the system which will allow to run?
So just a quick note on the format that this candidate's using here. This is a very helpful template that I'm seeing more and more people follow. I don't know if there's some guide somewhere or some book that is telling people to follow this template, but I kind of like it as an interviewer. It's nice to go over the requirements and then do like some back of the envelope capacity and then get into the high level requirement stuff. It's just a nice communication helper.
Run the code and validate the solution, or we may assume that it's already there.
No. This part we have to design. Part with login, registration, and so on. It's already done. Yeah.
Okay, so good. Just quick notes somewhere there. Notes login and half are done. Solution validation is not. Okay. Functional requirements are actually kind of like the same, so I can just basically move it there. So we define a system which should, first of all, allow people to validate their solutions and create a leaderboard, right? So validate solutions and place participants in the leaderboard. And I guess that leaderboard should be persistent, right? We should store it somewhere for some time, please. Okay, so what about the non-functional requirements? The first thing comes to my mind is availability. So basically, it's a time-constrained event, and during this, people should be able to work with our system. It should not break at any time, right? Because it's really important for people to be able to submit everything. So availability is important, I guess. High availability. We may talk about if we aim to some specific numbers, but if we think about 1 hour contest, I guess it just should be within the 1 hour. It should be high level. About the data persistency, I guess it should be persistent, right? We should store the leaderboard at least for a pretty long amount of time, let's say for forever. The same actually for submitted solutions. We should not lose them, as in that case,
No.
Yeah.
Let's keep only a leaderboard for the beginning, and solution we can forget.
Okay. Persistency, only leader. Okay. What about consistency? If some player will see slightly stale data in leaderboard, is it okay, or we should keep it really consistent?
Let's discuss it. Do you think from product, from customer experience, it would be good that sometimes they see they rank not properly?
This is a very good thing that the interviewer just did here, and look out for this. Oftentimes, especially if you're gathering this non-functional requirement stuff, you might ask your interviewer, like, hey, like what this candidate is saying, like, what degree of consistency should I apply here? And almost always the answer is, I don't know, what degree of consistency should we apply here? Because if you're going to be in this role where you're designing a technical solution, especially if you're in a senior position, you're expected to provide the trade-offs on behalf of the both your engineering manager and your product manager and so on. So any technical concerns that may have product implications, you have to be the one to surface. And it's good that this person surfaced them, but the interviewer is encouraging them to explore further, to be like, well, there's a number of options regarding consistency. What do you think is appropriate from a product perspective, given what you know about the problem? In the real world, you would have a product manager, or you likely would have a product manager help you with this, but still, you might not. So it's good to have an impulse to try and bridge those two.
It's a really good question. And if I would think about the real product, and I already worked with leaderboards before, my idea would be that within the 1 hour, we may assume that there will be stale data because, many players are updating their solutions. But after we have contest finished, we should calculate it, recalculate, update the leaderboard. And after that, it should be consistent all the time. But we should be able to tune this consistency within this 1 hour to achieve the best result. So from my perspective, we may live with some stale data within this 1 hour. But if the system requires having a strong consistency, I guess we can achieve that as well. It will be
I think
harder.
Your argument is very valid. Let's think about eventual consistency. I think it's fair.
Eventual consistency. Okay, got it. What about the latency? And by latency, I'm talking about not only the latency for the accessing the leaderboard, but also, I guess, for validating solution. I guess it should be as low as possible, right?
Yeah.
Latency as low as possible. Okay, got it. I guess that's mostly all so far, and maybe I will add some non-functional requirements which I discovered during the high-level design.
So, good job on the non-functional requirements. A couple little points, and this is more a matter of up-leveling the solution so far rather than any real strong criticisms. What does high availability mean? There's no qualitative statement of what high availability means. There's no quantitative statement of what latency should be. Persistence and consistency, those are fairly qualitative things. I think they do a good job here. But for high availability, you want to be able to say, what is my SLI for that? So my service level indicator. So how many seconds of downtime do I allow myself per month, year, quarter, whatever. Latency, like what is my P99, P90 latency for various things? It's good to be as explicit about that as possible, because if you give yourself a budget up front, then as you're building your concrete design, you can ask yourself, well, I have I'm making stuff up here. I have a 40 millisecond latency, but I'm trying to do this operation that's clearly going to eat up like half of that. Is that an acceptable kind of thing? Not a huge deal, but if you want to up-level your non-functional requirements, try to make them as quantitative as possible.
Do you want me to run back-of-envelope calculations there?
Or
we could just move on to level design.
Let's move. If we need it, we can calculate.
Well, I guess that what we can just do is to just define what data do we need for storing all this information, because and I will just estimate that, and we'll see what else do we need. So let's say our solution size would be something like about 100 lines of code, right? And that lead us to I don't know, maybe about 1 kilobyte of text, or maybe even less, right? And if we have millions of participants, I guess it should be something like, let's say, 5 million or so, right? So we get 5 gigabytes of memory required to store all of these solutions and submit them. And the leaderboard itself, if we just store the information about like the rank and for solutions, and for the leaderboard, we would require only really small amount of data, because we need to store some information about user, like maybe name, ID, profile photo, which actually may be retrieved from some user data table. So we assume that what we need to have is just an ID, which is 4 bytes, and their position. Let's say it's now 4 bytes, just the number. And we still have 5 million, and it would be just 20 megabytes of data required for leaderboards. So it's pretty small number. Or maybe we will need more to store additional information. Yeah. Okay. So I guess I can think from the high-level perspective, if you're okay with that.
Yes.
Okay. 1 second. Good. So from the high-level perspective, how should it look like? We have some sort of predefined tasks which we store somewhere, and every participant will access the same task, right? Everyone has the same task. I actually put it there. So tasks are the same for all participants. It's really important, I guess. And every participant accesses the same task. They have an access to our, let's say, just a text box there. We don't think.
One little tip, notice that as the candidate discovers requirements, they add them in writing. Again, optional. Oftentimes when you write interview feedback, you copy-paste the things that the candidate wrote in, or provide a link to it, as you can see here, because this is like a linkable location. The more you write, the better, because if your interviewer doesn't take a note that you added some requirement, then it's not going to appear in your record. Not a huge deal, because honestly, how often do people actually read the notes that you wrote, as opposed to just writing down a first impression? But the more product like artifacts you generate, the better.
Right now about the syntax highlighting and so. And when they pass the code, they will able to run some test cases, right? And validate solution. And what we should do, what the system should do when someone hit the run or submit button, we should launch our solution validated and compare the results and say, like, if it's okay, then we show the congratulations pop-up. If no, we show the test case where we failed and the reason why we have failed during the time constraints or because of the wrong output. And every time when we submit something, right, we record some sort of event, and we should process this event to be able to calculate the rank for the player, right? And when we get a quick question, if someone wasn't able to finish the contest, but was able to cover some number of test cases, will this person have some position on a leaderboard, or it will be just low? So should we take into consideration people who were not finished all the test cases but finished some of them?
Yeah, definitely, because our it will be a separate task, and if some participants finished some of them, it's already good result.
So if participant finished only some test cases, they already have a rank. Okay. That's really good. So basically, we process these events and we are building leaderboards, right? And I guess mostly that's how it should look from the high-level perspective. So I will just try to define it here. So we have our user, right?
I'm just going to jump in here for a second and say, it has been 15 minutes and 30 seconds of this interview. So like realistically, a third of the 45 minutes you're going to spend working on the problem. This candidate has spent reviewing the requirements and nailing down edge cases. That is good. These questions are purposefully vague and they purposefully leave out important details. And your ability as a candidate to detect what's missing and try to fill that in, that's a big part of evaluation. Right, a big part of systems design is we have this vague and non-specific thing that we want to build, and your job as a systems designer is to take vague and non-specific and turn it into specific, detailed, and well understood. So this candidate's doing a good job. The first 15 minutes, well spent.
We have our load balancer somewhere to distribute the workload evenly, and we have our let's say contest server, right? The contest server is responsible for accepting inputs from the user and running the at least maybe not running directly, but assigning to run this solution to check it out, right? And also what we have, what we need to have at least there, we would need to have some sort of database to store the information about atoms for the user, right? And I will dive into how are we going to validate solutions, but let's say we have this result somehow. So we have an event coming from the contest server or from the server responsible for running everything, that we receive the event, right? So event or so, right? And we put it to our database, and we will need to process it somehow and to be able to build our leaderboard. The reason why I asked about the consistency is that we may actually, as we may have it kind of high load, we may split this event processing. So let's call this part as stream processing, because we have just big number of events. We may have our stream processing pipeline as just a number of some jobs responsible for calculating the data, But also what we can do, we can also, in this stream processing pipeline, split our path to hot and cold, and hot and cold. And hot will mean that we build our leaderboards, update our leaderboards really quickly, but maybe with some non-really precise data, but it's highly available. And in cold path, we'll spend more time to update the leaderboard, but the results will be just precise. So I would put it as a stream processing pipeline, and I will just cover that later there.
Mm-hmm.
And within, so here we go, stream processing pipeline. And an output of the stream processing pipeline is a leaderboard entry, basically, or maybe even the whole leaderboard. And then when we have this leaderboard, we put it to some leaderboard database, right?
Mm-hmm.
And leaderboard database should be accessible to user. So I guess we should have something like that, LD, and we have our app service, which is responsible basically for everything regarding to the communication. And the app service will access the leaderboard database to show to the user actual leaderboard. And what we may also want to have is to have some sort of cache layer there to cache this leaderboard for some time if we expect really big load on this leaderboard, right?
Mm-hmm.
And next part is the contests. Just want to clarify, does it seem reasonable right now what I was saying so far about the stream processing pipeline and building the leaderboards in the background?
Yeah, it's fine.
Okay.
So let's take a step back and look at what the candidate has done so far. Notice what we haven't talked about. We haven't talked about database schemas. We haven't talked about, the finer points of load balancing or sharding, or we haven't talked about what kind of technologies we're going to use, right? We just say there's going to be a DB, right? That's it. This is good. You may think that this may seem a little non-specific, but this is what you want to do. Systems are best designed, or rather communicated, in layers. And what the candidate has done here is they've laid out the components of the system run. So you got, user, talks to load balancer, contest server, etc. And they've communicated what the interactions across those components are going to be. So the contest server outputs the attempt event, and then that gets written to the DB and so on. That's very good. The first level in a multi-layer description of a system is what are the components, what are their inputs and outputs, and what components talk to one another. And only when you have that laid out in its entirety is it time to start talking about the internals of those systems. So I, as an interviewer, I can look at this and say, all right, cool, I see the entire system and I buy it. I've seen similar systems before. These interactions look reasonable to me. It doesn't seem to me like we're imposing unreasonable and impossible to satisfy requirements on any of these components. So as in terms of evaluating this candidate, I can say, all right, great. They have a reasonable grasp of what components are available and how they can be structured together. And now the next question is, let's dive into each of those components and see how those requirements are delivered.
So about the contest server. Our contest server should accept the input, as I said, from the user, and should be able to run first of all, it should give the player the description of the task and some test cases. And it should be able to run the solution and check it against some test cases, right? How it should work? From my perspective, what we should do, we should be able to run solutions quickly. At the same time, the solutions should not intersect with each other. So if we run some really, let's say maybe even malicious code, it should not affect any other code running on the same machine, right? Because it will be problematic. Or if some solution just grabs like gigabytes of memory, it should not affect other solutions running on the same server. So that led me to the idea that we want to run these solutions, to test the solutions in some sort of containers, which will have some predefined amount of memory, and that actually may be a really good idea, as in every task in a lead code we have some constraints for memory and for time, right? And it may be also somehow maybe somehow combined with constraints of the virtual machine, right? So how should it look like? We have our contest server, which is basically responsible for getting the information about the task. So I would put it just get task path. And in this get task path, what we need to do, we need to go to some data store, basically, and get this task description and some sort of test cases. So I guess it should be something like task database, because, well, let's imagine the average size of the task description. I guess it should be about 1 kilobyte, right? And I will put a slash here because maybe we do not want to store such amount of data in a database itself. Maybe we want to put it to some object storage, and in database we will just have a link to the text which lies in the object storage. But nevertheless, the contest server should query the task database and get the description of the task and get the object of description from the task object storage, combine them together and get the response to user, right?
So if I'm reading this correctly, he's proposing like an object storage solution for the task. If I'm reading this correctly, the task is the same as the particular contest that the users are working on. That seems a little bit heavyweight. It's unclear to me if he envisions this task DB as being co-located with some other database, but that seems like a lot of design for something that could be quite straightforward.
And what I see here is that every user will basically get the same task every time, right? They just solving the same task, so it's really reasonable to me to have a cache layer there, just for the sake of availability at low latency. So by having a cache, and as we have like maybe 1 or 2 tasks or so, maybe even 5 anyway, it shouldn't be a big chunk of memory. We just store it in cache, and every user just should get it instantly, right? Okay. What about the submit path? There goes like lower. Okay, here we go. So it's a submit path. And what do I see here? What we can do, we can, every time when user attempts to run something, have a new virtual machine running this code. But I guess that would be not really effective. Why? Because we will need spend some time for startup. And for small solutions, this startup time will be even bigger than the running of the solution itself, right? And that will lead to unnecessary latency. So my idea is that when user loads, contest server will be responsible for create virtual machine for the session ID. So what we do when user enters the contest server already creates a virtual machine associated with the session ID, and we already have it somewhere. So basically, we will not need to recreate it for every submit. What we just need to do to just run the code and clean up after that. and it may lead to some load on the server, but as we do it only for 1 hour, maybe we can just leverage it. And also, we maybe do not create it just from the start. Maybe we will want to, create it for the first submit and then keep it, as we already find out that user is going to solve the problem and not just looking at it. Does it sound reasonable?
So does it sound reasonable? This is where I start saying, wait a second, that's how you want to handle this? Because what they're proposing is to create a VM on a per session ID basis. And what's challenging about that is that VMs are quite heavyweight. And if I'm understanding him correctly, he's proposing to have millions of these VMs simultaneously. I can't tell if the contest server is going to be one server, probably it's going to be multiple, but still, we're talking millions of VMs. To my knowledge, there's not a lot of hypervisor solutions that can give you millions of VMs per machine. Maybe if you use containers, it'd be a little bit more realistic, but that seems heavyweight.
Yes.
Okay, so we have our submit path, and we have our virtual machine running, or not yet. So if it's running, that's good. If it's not running, we should create this virtual machine. And the virtual machine service will be responsible for that. I guess there may be some solutions helpful there, but anyway, for me, it's just some Docker image running with some predefined rules. And yeah, I will dive into that later to be able to understand how should it work properly. And the content server is responsible for validate the solution in virtual machine, and it should keep an eye on the virtual machine to check it out what the result is. And if the result is successful, we should, nevertheless of the result, we should put an event, right? Put an event, and in our to process it later, right? And if the solution is okay, what we should do, we should, I guess, we should have we have our leaderboard, and I guess we can just reuse it for the same purposes. We have some sort of contest database, and maybe I guess it's even located somewhere near the leaderboard database. So if the solution is good, we just put entry to the contest database and to the entry to contest DB, right? And starting from that, we assume that the user finished the contest. And so that's the question. When user submits working code, should we allow him to resubmit to get more, to get better results, or we just count on the first submission?
No, number of attempts are not limited. If they want to improve their solution, it's
okay. So that path may be optional here, I guess, because in that case, in every case, we just need to put an event, right? So that's how it looks like, and I will maybe do you want me to dive more into the virtual machine service, how we should allocate machines, or you want me to jump to the stream processing service, to the stream processing pipeline?
Just a second. I have one question. Is it correct understanding that if we use session ID, user once joined to our contest, every time it will be directed to the same server machine?
Yes, that's the idea. Well, no, actually not. we should be able to create a virtual machine associated for the user with the session ID, but it doesn't mean that it should be stored on the contest server itself, right? So we may have stored this information, let's say here, somewhere there, from the cache, right? It will be somewhere around the virtual machine service. So that means that every time when user reload the page, he can go to every contest server, but every contest server will know about the virtual machine associated with this session ID. So that's the idea.
So this is a very interesting question that the interviewer just asked. If you didn't catch it, let me recap it. The interviewer is asking, I can't talk, sorry. The interviewer is asking if a user sends a request, will that request always be handled by the same contest server? That is a very interesting thing, because usually when you have these servers that are handling requests, they're stateless, right? There's no need to always send the same request or from the same user to the same server. They can in principle handle them, any request from any server, and then downstream from that, you have whatever state you need to maintain a unified experience across contest servers. But this VM is tricky because this VM has to exist, if I'm understanding this correctly, in the contest server. So as a result, the candidate seems to be flirting with introducing stateful routing to the load balancer, which is it's not impossible, but it is quite a heavyweight and complex solution to have such a stateful tie between a session ID and a server. Because think about it, what happens when that server goes down, right? That session basically dies. What happens when the user shows up and issues multiple requests? The load balancer needs to maintain a mapping from user to server. And what's more important, the load balancer now needs to store more state regarding the pool, regarding the state of the pool of servers running in the contest server component. So the answer from the candidate is no. We're going to serve non VM requiring tasks. So things like, what is my task? What are other HTTP type interactions? We're going to serve those from a cache, but the VM is going to remain persistent. And this is my biggest criticism of this solution, is that the candidate has introduced a stateful mapping between a user and a VM, and that mapping has to be maintained somehow. Requests from that user must be sent to the VM. If the VM dies, if the machine that the VM is running on dies, if anything happens, the user is left in this dangling state where they have to recover their state. It actually gets a little bit worse, because even if you can make all that happen, that's a very inefficient solution. Think about what we're talking about here. We're talking about having millions of VMs running concurrently with stateful mappings, of course, but we'll sort of let that slide. These VMs are running concurrently, and for the vast majority of their existence, they're doing nothing. They're just sitting around waiting for their dedicated user to ask them to validate a request, which is a lot of wasted resources. Like, VMs are not small objects. They take up lots of memory. They do have, because they are virtual machines of real operating systems, they do have background tasks that consume CPU. So I don't like this, to be honest. I think this solution has some serious flaws.
Okay, so it means that if some contest server failed, request,
that means that if some my idea is to have the contest server, maybe it wasn't clear from the description, but my idea is that we will need to have contest server really stateless and to store all the information in separate servers. And in that case, contest server will be really easy to replace in case of failure. So yeah, that's the idea.
Okay, yeah, that's clear for me. Yeah, let's move on.
Okay, so let's talk about the stream processing pipeline, because that's not covered yet. So my idea here is that we will get many events coming within 1 hour, so it will be pretty dense pipeline.
So before the candidate continues, I'd like to give some comments on how I would approach this. So to put it bluntly, I don't like this VM-based solution. I think it's very heavyweight. It wastes resources. It introduces unnecessary complexity in things like routing and state management. The way that I would handle it is, instead of having a one-to-one mapping between users and VMs, I would just maintain a pool of VMs that are responsible for executing tasks. The candidate correctly identified that this is a security problem. What you're doing is you're effectively running arbitrary code, which is like exactly what you're not supposed to do. So the solution involves building a degree of isolation between individual tasks running concurrently on the same machine, which is good. And this is doable from using something a little bit less heavyweight than a VM, but it does require some security knowledge to get right. And like, this is not a security interview. I don't expect them to have this level of detailed knowledge. But still, I'm a little disappointed that they didn't recognize the complexity with the solution that they're proposing. The way that I would do it is I would propose to do the heavy work of building an isolation capable server, so that rather than spinning up an entire VM or an entire container, it just receives a task, executes it, validates whether it's correct, and moves on, and then moves on to the next one, most importantly. So a single validation server would be responsible for chugging through lots and lots of tasks, and as a result, you can have many, many, many users using a single validation server, except spread out over time. Whereas here we have many users using a single validation server, except it's spread out over space, quote unquote. It's spread out over memory and VMs and so on, and that solution doesn't scale. There's one more thing that I want to point out about this solution, and this is kind of a subtle point, but it's worth pointing out. The flow that we're following here is first when we perform a submission, first the submission goes through to validation. And then after validation, the outcome of that validation is sent to the database, which means that if that machine dies, that task dies with it. So there's no persistence event prior to validation. All it does is it hits the server, it becomes validated, and only on validation completion does it actually get persisted to the database. That's a recipe for data loss. What I would recommend they do is swap the order. First, write it to the database, and then have it consumed by a validation task or a validation server, so that even if that validation server dies, the write to the database has succeeded, and we have that data safe and sound in a persistent location.
So my idea here is that we will get many events coming within 1 hour, so it will be pretty dense pipeline, pretty dense stream of events. Let's imagine that in average, like we have 3 atoms per people, so we'll have 15 million events within the 1 hour, right? And that means 15 million. And if we divide it by 100K, and I just let's imagine that we have I don't know, it's not 100K, it's 360 seconds, right? So I will divide it, and we have, okay, and I guess it's something like 400 RPS, 400 events per sec. So it's pretty big numbers, I guess. So again, my idea is to have 2 paths. So we put all information in a database. Database itself is just append only. So DB append only. So we just add the event and we forget about it. So that should be really easy. And then what we use here, we should have our database as a single source of truth for these events, but we should be able to process only new events. So there is a structure called change data capture, which basically the database commit log created in a form readable for other services, or it may be as well be described as a Kafka log. So I will not put Kafka here just for the sake of keeping it service agnostic, but it's just a log, basically, log of events with offsets. And we have one stream pipeline, one stream processing service, which is responsible for both building leaderboard online and building leaderboards with the precise data. So we have our hot path, as I said before, and we have our cold path. And the reason why I call them like that is that it's what I will just describe right now is called as a lambda architecture. So when we have hot processing, so it will be just process data real time, and in cold we process it slowly, slow processing, and then what we do, we just combine all these results together and merge them together to get the precise data and update our not really precise data with from the real-time calculations with the data we have in slow processing. Yeah? And we have this leaderboard DB. So how it will look like? When we have this hot processing, we will have these events come into the hot processing, and we will need to calculate the rank really quickly, right, to be able to display it in real time. So we have our service for creating the rank, right? We have many things for rank calculation, but we should make it really quick. And my idea is that we may have some sort of probabilistic algorithms in hotpath, which will allow us to have maybe not really precise data, but it will allow us to have this data calculated really quickly. So I will put it as just probabilistic. Right? Algorithms. My idea is that we may use count means q here. No, not count means q. I mean count means sketch, so it's called. Which one of the algorithms are really useful for such type of calculations. So based on that, we will be able to calculate not really precise leaderboard entries, but in a slow processing, we should calculate every rank appropriately, right? We should take into consideration all the facts we know about the user, the time of solution, all the solutions, aggregated number of attempts, aggregated number of memory, right? The best attempt, and etc., etc. Time required for the first solution, so on, so on. And it will be a bunch of criteria there. And my idea is that we may have some sort of as a MapReduce jobs there to process all the events together. And we may do that periodically, maybe like once per minute, or so. It should be configurable, of course. And after we have these MapReduce jobs completed, we just merge this data with the results from our probabilistic hotpath inside the leaderboard. That will mean that we will get the consistency within our time of MapReduce job, our MapReduce interval. So if we define it as once per minute, we will have our leaderboard updated within 1 minute. We may configure this value to be like once per 30 seconds. It all depends on our requirements of the system and our resources, right? So that's how it should look like from the stream processing pipeline, I guess.
All right. I disagree with this design. So if you're familiar with the pattern, or rather if you're not familiar with the pattern that the candidate's applying here, this is called the fast path, slow path design. Oftentimes you get situations in which algorithms are very expensive to compute precisely, but fairly cheap to compute approximately. A good example of this is, imagine your Google Analytics and you're receiving this like absolutely enormous volume of traffic, but some portion of that traffic is going to be like bots and spam and things you don't want to count. But detecting those things is slow, right? How do you know something's a bot? You might not know until way into the future after you've analyzed that particular source's traffic. So a fast path, slow path design allows you to apply a very fast approximate integration. So in the case of Google Analytics, you imagine naively speaking, we're just going to assume all requests are valid. And then you have this cold path or this slow path, which does a more precise calculation, but it does this like much more slowly offline. So what you get is this pattern in which you run the slow path and you get like precision, and then you gradually deviate from it as you run your hot path, and then you boom freeze and compute a more precise value, and you reduce those deviations and you kind of build up. And this way you can control the size of the deviation from reality by how frequently you run your cold path. The reason why I don't like this is that you're kind of this candidate's kind of driving a nail with a sledgehammer here, right? We're talking 400 requests per second on average. So let's say, if it's not distributed evenly, up to 4,000 requests per second. That's not a lot of requests. And the thing that they're trying to do is maintain a ranking. You don't need a terrible amount of sophistication to maintain a ranking. I mean, all you need is to maintain like a red-black tree or another balanced tree on the back end in memory, by the way, because we're talking like millions of items, which even if each item is a kilobyte large, then we're talking about like gigabytes of RAM. You can totally store this in memory. All you need to do is update some red-black tree or some other balanced tree in the background on a per request basis. And that's very fast, especially when you do it in memory. So I mean, MapReduce. MapReduce is an expensive computation, right? MapReduce is where you fan out across multiple shards to process a very large data set, and then you gather the results and combine them all together. That process alone is not worth doing here. For what it's worth, very simple solutions, very common solutions like Redis, so an in-memory cache, literally has an application or has a table type that is dedicated for this use case. It's called a sorted set. It maintains exactly this sorted data structure that I described in memory, and it updates it in memory very fast, and it can handle thousands, if not tens of thousands of requests per second without breaking a sweat. And through things like snapshots, it can give you approximate persistence as well. So I don't know. This solution feels like overkill to me.
Mm-hmm. What's worth to mention there is that we also may want to update the cache itself. So we would need not only update the leaderboard database, but we also may want to update the cache because we don't want users to see the stale data. So there are a couple of solutions here, each one with their own trade-offs. The first idea is that we may have write ahead cache or so we may update cache and leaderboard DB simultaneously. This solution may work, but it will lead us to additional latency in updating the leaderboard. And the same approach is that we have some sort of, as we know that we run MapReduce jobs in an interval, we may have some sort of TTL within the cache. And when the user requests the leaderboard, we basically check it if it's in cache. If it's expired, we just go straight to the leaderboard and put it in cache. So we have two solutions there, and I would put it as a just there. Maybe we'll have some time to discuss. But if you want, I can just discuss the stage-offs and decide what can we do with the cache itself just right now.
No, it's okay.
So this cache portion, I actually think is kind of wise. Even if you take this Redis in-memory sorted set approach, actually mapping each user to their position in that sorted set, that is not an expensive thing because you can do that very quickly, but it's not free because you're talking about basically dumping the entire state of your ranking and saying, here's user 1, here's user 2, here's user 3, and so on. So maintaining that ranking is incredibly cheap. Dumping that ranking is not cheap, but it's not expensive either. A cache will allow you to do that. So imagine you have a cache that has a time to live of, let's say, 60 seconds, and every so often you will do the operation of dumping the entire state of the rank, which might take, let's say, 300 milliseconds. Not slow by any means, but also not fast enough that you want to be hammering the hell out of Redis the whole time. So a cache is a good thing to add here.
It's okay that what you explain, it's enough.
Okay, good. So what else here? We have our virtual machine service, and it also has some sort of cache. Well, it's not really a cache; it's just some sort of like cache DB. When we associate session ID with the virtual machine service. So I will just should tell a couple of words about the virtual machine service. Virtual machine service should be able to allocate new machines for the session ID. It should shut down machines after the interval. And also what it should do, it should also have a database, have a cache database with key value pair, I guess, key value pair for session ID and machine ID. And it should be able to actually run the specified code on this virtual machine. This four number leads me to interesting question about the security itself, right? Because we do not want to be able to run arbitrary code, and I guess we should be able to limit the number of possible operations by having everything running inside the Docker or virtual machines, but anyway, that brings some security concerns as well. So we should disallow some malicious code, and we may have some sort of service responsible for checking the code before that, importing some bad libraries or using some sort of URLs. I guess that may work there. And after the running the code, it should also report the results, right?
So to chime in, requirement number 3, have this DB key value pair from session ID to machine ID. Notice that's the extent of state management from this candidate's design. There's no discussion of how you're going to map from a contest server that's handling a request to the machine ID. So there's got to be some kind of network mapping happening there. The next thing is what happens if the machine dies. We don't know. And finally, we have no discussion of the fact that this is a very resource-heavy operation. But they do have a good. They do correctly point out that there are security concerns here. This is a very non-trivial thing to do from a security perspective.
Okay. It seems that we have 4 minutes left for the interview, and I may go through how the system should work on under the load and cover all the.
No. It's already enough. It's deep enough. Could you maybe go through this your design and maybe explain me some more trade-offs what we have and what kind of bottlenecks and how we will scale it?
This is a very good question. For what it's worth, the candidate offered to talk about how the system will handle load. In this case, the interviewer feels that it's not helpful. That's at their discretion. That's a good thing to offer, by the way. How do we handle increased load? Like, what knobs do we have to turn to make the system larger or smaller based on the load that we have? But instead, we want to the interviewer's going around and asking, well, where are our bottlenecks? So let's pay attention to that. It's a very good question.
So about the content server, as I said, the content server itself should not be really responsible for storing the information itself. It should be just, putting some calls to WAM servers or putting some events to the database. So if it dies, it shouldn't be a big problem for us because load balancer should be able to just locate another context server. But it may be a problem if the context server dies after we get the response from the virtual machine and when we get the attempt event sent to the database.
Very good point. I pointed this out earlier. It looks like they've caught on to this constraint.
Because in that case, user may think that, okay, my request failed and actually it's already there. But if we may query this database and we also may have some sort of cache for the user itself. So I'll put it as a cache for user events, because actually what every user should see is the history of his attempts. It's really important. I completely forgot about that. So we may store it in cache, and if the server dies on a way to get the response, to send the response to user, when user reload the page, it will see that actually attempted event was sent, and he will see that in his history, so it should be safe.
It's not clear to me why it should be safe, because maybe the candidate is thinking of something different. But when I hear cache, I think something in memory. So then, fine, all right. Well, if the server dies and it's available in cache, that's great. But what if the server and the cache dies? And I don't want to hear how often is that going to happen, because as a rule, if something can happen, it will.
By having a load balancer with some mechanism like round robin with health checks, we will be able to distribute the workload between context servers evenly. Database itself will accept many events per second, but as we decided that it will be only append only without any changes, it should be able to maintain high write throughput, right? But we can use some of the solutions if we decide that it's not enough for us. We may use some of the solutions with really high throughput, like Cassandra or some other NoSQL solutions. What about the stream processing pipeline and the change data capture? Change data capture essentially is a lock, and it should be kind of safe to use it. And what we can do here, we can also introduce some sort of lock compactions to store old locks. And anyway, it shouldn't be really challenging, as we have only 1 hour event, 1 hour time frame. But also we may introduce partitions inside the lock to be able to distribute a number of events evenly as well. The stream processing service itself is a system, and it should be scalable and available as well, but I will look at these two parts. MapReduce itself is really fault tolerant because every job itself writes and reads from the disk, and if the whole pipeline fails, you should rerun only the failed part, and it is deterministic.
All right, so overall, how did this candidate do? First things first, their communication was very, very good. They communicated this high-level design. They communicated from a high level down. So they started off with all the components, what those components were responsible for, and how they communicate with one another. And then they dove into individual components to see how they'll deliver the things that they promised. That is a very good pattern. Highly recommend you follow that. And before that, they nailed down the requirements, because the requirements are vague and ephemeral, and you are kind of expected to fill them in a little bit. A couple things I disagree with. I disagree with the choice of a VM service. I think VMs are a little bit too heavyweight in this case. Probably more likely it would have been better to do things through a more stateless service rather than maintaining a session to VM mapping. One thing I will point out, though, is if you look closely at this design, you don't actually need to change anything to incorporate a new system or a new implementation of this VM service. You could replace it with this like backing stateless validator thing, and it'll more or less still have the same component input, output, and interaction structure. So that's a sign of a good architecture. My bigger criticism is for the stream processing pipeline stuff. They've put a lot of time and energy into designing something that, in my opinion, could just be a straightforward in-memory cache type solution or an in-memory data structure solution. This is a slightly bigger failure in my mind, because if you're applying for senior roles, you're going to have a certain degree of leadership responsibility. And if you're going to be a leader, you have the capability to waste people's time, right? If you design a system that is more complicated than it needs to be, or has more moving parts, or just brings too much power to bear, you're going to end up taking time and energy away from putting in place a simple solution and just moving on. So that's a bit of a problem in my mind. But overall, pretty good performance. In terms of how I would rank or how I would recommend, that's very, very dependent on the role and on the company. In my experience, this performance is consistent with like a decent hire at senior engineer. I'm a little bit ambivalent whether I would bring this person on at a staff level, primarily because of the choice to do this very heavyweight stream processing pipeline. However, based on their designs and based on how well they communicated, it's not out of the question that if I had simply pointed out like, this seems like kind of a heavyweight solution, they would just take it and run with it. So for staff, I would give them a weak hire, maybe a weak no hire. I'm on the fence regarding staff, but I would give them either a hire or a strong hire for senior engineer. To recap, for tips for you, first off, make sure you and your interviewer are on the same page about what you're trying to build. These prompts are vague, and your follow-up questions illustrate how much knowledge you have and how much understanding you are trying to bring to the situation. Second, structure your communication in two phases. You want this system components and input, output, and interactions phase. And then once that is described and you can see the entire system from end to end at a high level, then you want to go into individual components. You want to sort of hone in on the most challenging components. And finally, remember, don't overcomplicate things. It's not everything requires some complex distributed solution. If you can do something using a small solution or a small system, do it. You'll save yourself and your team a lot of time. System interviews are tough, but if you practice enough and if you're prepared, you'll do all right. I hope this was helpful, and good luck.